So let us open the backward trajectory now. Let's open with Chemcraft. And if I, so look it once more. Let me come to this one. So at this point, although it's, let me go to the first point. So here you can see it's bonded with the chlorine and the fluorine at a distance. Now if I come down little bit, maybe not through animation, maybe my using the downward key in your keyboard, you can see that now the chlorine atom is coming closer and the fluorine atom is coming closer and the chlorine atom is going away. So more and more you go, the fluorine atom is coming closer, so it's becoming CH3F, and the chlorine atom is going away, and at a final, when it reaches the finally it reaches the product form, reactant form. If I go into the forward trajectory, and maybe we will try the same thing. You can see that the fluorine atom is going away and the chlorine and carbon bond is becoming shorter and shorter. So, it is going towards the product formation. So, now my product is formed. So, in whenever case there is a doubtful that the transition state may not connect the reactant and the product, it is always advisable to run an IRC calculation. Of course, by looking at the mode of the vibration you can make a guess, but in many of the complex transition state it may not be possible to make a educated guess. So, it is a good idea generally to make an IRC calculation out of it. So, this is your first homework problem. You will find out the transition state between SiH2 and H2 leading to formation of SiH4. You want to do it via relaxed surface scan or NEB, it is up to your choice. I would prefer to do it via NEB way. And remember, as I told, transition state finding is often considered as an art. So, the more you practice that, more you become a master of it. So, we will do another problem which is slightly more complicated than the chloromethane and fluoromethane we have done. So, here we will show you some uses of Avogadro, because remember, whenever you draw the structure, you have to draw the structure in such a way to use it for NEB that your reactant and product remains at a very similar atomic number, identical atomic number actually. So, here we are going to do a larger example where we do the hydrolysis reaction of methyl ester and it will give you a product of an acid and an alcohol. So, basically will give you acetic acid and methanol. So, this is how the orientation of the reactant should be. This is what you understand from your chemical intuition, that the water molecule should have hydrogen bonding to make the reactant stabilize, and the way it will do the hydrogen bonding, that it will point one of the water hydrogen towards the carboxylic oxygen. So, this is how the reactant structure should look like. This comes from your chemical intuition, and to find out the reactant, product and transition state, you always need to use your chemical intuition. So, what suppose will happen is that, so this OH, this hydrogen from this water will add to this oxygen, and the rest of the OH group will get attached to this carbon to make it an acetic acid. So, this will come here and this hydrogen will get attached to this one. So, this is what we need to draw, and we are going to use the Chemcraft. I will try to do it slowly, so you get to see different uses of Chemcraft. I am not saying that the way what I am showing here is the only way to draw. There may be a better way to draw it, but I will prefer to use this one. And you can use actually Avogadro or maybe Chemirax to draw it. It is up to you what is your convenience. I find the Chemcraft to be most convenient to do the drawing. So, let us first make the methyl acetate. So I'll go to edit, add fragment. There may be somewhere an ester group. Yes, here it is. And then at this point, I want to add an CH3. I think I have added a wrong group. This is the group I should add, CH3. Yes, now it's become a methyl acetate. Remember, now I have to need to add in water. So I'll get simple compounds, I can get water. I can put the oxygen here. Maybe I should drag the water molecule a little bit close to this one. The way I will do the dragging is, I can do it in multiple ways, but I think I will add the drag option. But dragging time, I will drag fragments. And then I will go to the, so I have went to drag atom and drag fragments, and then I will go to drag atoms again. Maybe I should have dragged the full molecule. Okay, now I think this one should work. I again goes to drag atom. I believe now we are closer to than what we have before. Yeah, we are closer. So now, of course, this is the guess of the reactant structure. So now I have to optimize it. Save structure as XYZ file. And this I will do inside. It's a big directory. So this I will write as reactant.xyz. So I open this one with Notepad. Here we are going to use XTB. So XTB opt, most probably will go to a minima. It is very unlikely that we will go to a frequency calculation. We told that this, for this calculation we are going to use XTB. Just to copy paste the recalculate Hessian keyword. No, like most of you, I don't remember the command by my heart. I just copy it from some old input file or the internet. So what happens is that if you are doing it regularly, you generally remember the commands by your heart. Even if you have poor memory like me, it's not a problem. You can always copy paste it. And one. Okay, the one change I need is that I do not want to calculate the Hessian as the IT5 step. Because that sometimes if you recalculate the Hessian too quickly, sometimes it makes your optimization less stable. So this I will save as reactant.inp, close it from here. I open the terminal here, MobiXterm terminal. I make the terminal zoom a little bit. So my reactant job is running. By the time I can make my product. Maybe I should wait for the reactant to get into a proper optimization structure, and then we can start making the product structure. There is an error. So sometime it has happened that the initial optimized structure is not very proper. So what you should do in these cases is that at fourth optimization it has been giving you an convergence issues. Let me see that. So when you see this kind of a problem, first you try to see what's went wrong. It's a good idea to look at the output file. So this is fine. Now what I will do here is that I will again open it with ChemCraft. So this one start to get a form of bond, which it should not happen. That means now what I should do is to drag the water molecule slightly away from it. The way I will do it is that first I will make sure that this two does not have any bond. So remove the bond, and then I will drag the molecule slightly away from it. So I will go to the dragging type, drag molecule, and drag atom, maybe slightly away from this one. This might be a better orientation. So sometimes this kind of things you have to do. I have to again save the structure. Let me copy paste it and replace the reactant.inp. Save it and let us try to rerun it. So this has been done now. Once it has been done, I should open the output file and try to see if I have got a reasonable structure. So this is the minimum energy structure. Looks reasonable to me. Now we need to make the product. To make the product, we have to first do few things. So the first thing we need to do is to remove the bond between the carbon and the OCH3 group. Next thing, I should remove the bond between the oxygen and hydrogen, and also I should remove, although this is a hydrogen bond, I should remove this hydrogen bond also. And then I will create a bond between these two. And maybe okay, I could have bring it little bit closer and then make the bond. So I will use the drag atom command. I will bring it closer, and now I will create a bond. I could unclick the drag atom. I could have used Control D also. I've created the bond. Okay, I'm almost there. The only thing now I have to do is that I have to drag the alcohol fragment. I Control D. I have removed it, this one. Now I should drag this OH close to this one. And create a bond between the two. The structure is still very strained, but they look fine for the time being. Of course, we need to save as an XYZ file. I can write it as product.xyz. So I open the product.xyz. I open it with Notepad. I copy this to one. I went and I rewrite as this one and write it as a product.input. So like the similar, I am making an input file as the reactant was. All files. So now I will run the product job to optimize the product. So I've done so much operation just to make sure that my product is created from the reactant. You could have done the same thing. You can start it from the product and reorganize the bond so that it becomes the reactant. This way you make sure that your reactant and product follows the same connectivity. Sometimes what happens, if your structure is very off from the equilibrium, it's a good idea to recalculate Hessian maybe after 15 or 20 step. 5-step Hessian calculation may not be a very good idea. So now finally it has been optimized. So let me go and see the product output file to make sure that we have get everything correct. So the product structure at least looks fine, it's properly hydrogen bonded. So my reactant and product is ready. Now I'm ready to run the NAB job. I can make the NAB input file from the scratch, but I will be my lazy self. So I will use the NAB input file just one directory before, which I have used previously. So everything will remain same. The only thing is that now it's 0 and 1, and I save it inside the baked directory as a nab.input file. So I have the reactant, I have the product. Now let me run the nab. There is a mistake I have done. And don't forget to replace the PM3 by XTB. Orca nab.inp. because I have given pre-op 2, it will try to optimize it, but because the reactant and product structure was pretty close, so the optimization should not take so much of time. So now my job is complete. It took me 8 minutes. I can open the neb.out using my Chemcraft. So this is the transition state looks like, and if I look at the imaginary frequency, you can see what's happening. So this water molecule is sandwiched between the carbonyl oxygen and this methoxy group, and one of the hydrogen is going to the methoxy group, and this one is actually linked with the carboxyl oxygen. So this looks like a correct transition state to me. Of course, you can do an IRC calculation, which I will skip it here. As we have discussed, that this will require much more practice. So, I will give you 2 more homework problem. One is the finding out of acetaldehyde to vinyl alcohol using the same XTB. You can use RelaxScan or NEB, whatever you like, and there will be a slightly difficult problem. This is an optional homework problem where you see a Diels-Alder reaction like this, and this we will actually do both using XTB and if possible using some DFT method, maybe BP86, because here the molecular orbital orientation actually gives you a lot of information about the reaction, and you can see how the transition state will look like, what kind of alignment it should has by doing this kind of calculation. So, this we will do it separately. It is an optional problem. If you do not want to do it, you can skip it, but we will anyway solve it in next week and try to get some information about it to understand how the molecular orbitals can give you idea about transition state. So, this is for this week up to now. So, at this week you learn 2 things. First of all, how to do thermochemistry analysis, how to go from only electronic energy to the thermodynamic quantities using frequency analysis. And the second thing you have came about how to do transition state, how to find out transition state. You have seen 2 options, relaxed surface scan and NAB. NAB is generally the more straightforward way, although it can be very time consuming. So, most of the time we are using semi empirical method like PM3 or XTB, but maybe in real life you want to do some level of high level calculation, maybe some DFT. So, in the case of transition state finding, Hessian actually plays a lot of role, and some of the difficult optimization also Hessian plays a lot of role. So, whenever your structure is not converging, try to see what is going on, open the output file, try to visualize what is going wrong, maybe rearrange the groups a little bit more, do one more Hessian calculation, and then with some trial and error you should be able to make. So, next week we are going to know about methods. So, up to now we were dealing with only one kind of method. So, when we are doing calculation, whatever we are using, the whole molecule is treated using a single method, may DFT, MP2, couple cluster or XTB. So, in the next week we are going to go into a multi-layer modeling where different parts of the molecule will be treated at different level of method depending upon how important they are for the corresponding chemistry. See you next week.